Dividing complex numbers. So this is where we're going to see our complex numbers in the denominator, because every fraction is division. We do not want our complex numbers in the denominator, and how we get them out is we will be multiplying the top and the bottom by what we call the complex conjugate. Okay, basically we're going to use the exact same terms, we're just going to change their sign. So what that looks like is I'm going to multiply the bottom. It's kind of like rationalizing the denominator that we did in Algebra 1 with radicals and in geometry as well. Okay, and then I'm just going to distribute that 9 to the 3 and to the I, so I get 27 plus 9i over, and again this would be like the FOIL method. 3 minus I times 3 plus I, so it'd go over, over, under, under. So 3 times 3 is 9, 3 times I is 3i, negative I times 3 is negative 3i, negative I times I is negative I squared. Okay, and then we can just clean this up by combining like terms. You'll see those terms in the middle. They'll always cancel. That's why we are using the opposite sign, so we see that happens here. And then we're just going to, let me go ahead and rewrite this. So it'd be 27 plus 9i all over 9 minus I squared. Okay, now we know that I squared is negative 1, right? So this becomes 27 plus 9i all over 9 minus a negative 1, which is a positive 1. So we get 27 plus 9i over 10. And I really struggle reducing fractions looking at them separate like this, and we know as complex numbers we want that I term at the end by itself, so I would split this up and say 27 over 10 plus 9 over 10i. Okay, let's try that again with another example. Let's try 80 over 2 minus 6i. Okay, again, we do not like those complex numbers in the denominator, so I will multiply the top and the bottom by the conjugate of our complex number. So same terms, different sign. Okay, and then I will distribute that 80, and I get 160 plus 480i. And then I'm going to do my FOIL again, over, over, under, under. We want everything multiplied by everything, so I would get 4 from 2 times 2. 2 times 6 is 12i, and then negative 6 times 2 is negative 12i, negative 6 times 6 is negative 36i squared. Okay, looks kind of crazy, but once we clean up by combining like terms, it's not going to be too bad. So you'll notice your i's in the center cancel, and remember that our I squared is negative 1. So I get 160 plus 480i all over 4 minus 36 times negative 1. Okay. Coming down, we get 160 plus 480i all over 4 plus 36. And the more practice we do with this, the more steps you'll be able to skip, because I mean, some of you might already be able to skip from here straight down to the 40. Okay, I'm going to go ahead and split that up. I get 160 over 40 plus 480i, 40 over 40. And when I simplify this, I get 4 plus 12i. So look how complicated it really got right here in these steps to just simplify so easily. Okay. I'm going to go ahead and set up a new example. I want you to pause the video and try it. and then come back, restart it, and let's work it out together, okay? Alright, here we go. So again, same terms but different sign. So this time it will be -1 minus 2i, -1 minus 2i on the top. Complex conjugate. I'm going to do a lot of over, under. Everything gets multiplied by everything else. So I'm going to take my time here, make sure I don't mess up on signs. Negatives always get me. So 4 times -1 is -4. 4 times -2 is -8. Keep my I. -3 times -1 is a +3. Keep the I. Negative times the negative is a +6. I squared on top. Okay. -1 times -1 is a +1. And then I get plus 2i minus 2i minus 4i squared. Okay, we can clean this up right here. We can combine like terms, so I'm going to get a -5i here. I'm going to multiply that by -1. This I squared becomes a -1. And when I combine down here, those actually cancel out. So what am I left with on top? I have -4 minus 5i. 6 times -1 is -6. And then on the bottom, I have 1. My i's canceled. -4 times -1 is a +4. Combining like terms again. Remember, numbers can go with numbers. Just make sure you only combine numerators and then combine in the denominators. Okay, keep those separate. And we get -10 minus 5i in the numerator and a 5 in the denominator. Go ahead and split that up. It definitely makes it easier, I think, in reducing, and I always encourage splitting those up just because that real big fraction stresses me out when it comes to reducing, and I always end up forgetting to reduce one. I'll reduce this way, but I'll forget to reduce this one. So keeping it separate sure helps, and we get -2 minus 1i.